Hello, this is Eileen, the environmental educator, and in this video, we're going to talk about some of Alaska's pristine rivers that are turning a rusty orange, and it can even be seen from space. And they say it's likely because of melting permafrost. So this is a May 22nd, 2024 article. It's Business Insider. It's over here at phys.org too. Alaska's rusting waters, pristine rivers and streams are turning orange. And this is May 20th, 2024. So this right here is in this video down here at the point where they say it can even be seen from space. It's so orange, so prevalent that it can be seen from space. And they say that, well, right here, this is an aerial view of the Kutuk River and the gates, gates of the Arctic National Park in Alaska. So that's inside of a national park, and it says that dozens of Alaska's remote streams and river are turning from a crystal blue into a cloudy orange, and the staining could be the result of minerals exposed by thawing permafrost, according to new research in communications, earth, and environment. So, researchers from the Park Service, the U.S. Geological Survey, and the University of California, Davis, and other institutions have documented in samples some of the impaired waters, pinpointing 45 locations across a Texas-sized area of northern Alaska's Brooks Range. So they said, this is the first time that they're doing this research. The degraded rivers and streams could have significant implications for drinking water and fisheries in Arctic watersheds as the climate changes. And, they say the more they flew around, the more they noticed more and more orange rivers and streams. And they say that those, can be problematic both in terms of being toxic, but might also prevent migration of fish to spawning areas. And so they first noticed this when they visited a river in 2018 that appeared rusty despite having been clear the year before. And so they started getting water samples, and they took helicopters, to remote regions because it's the only way in. And yeah, right here, they say that they're so big they can be seen from space. And that's according to this Brett Poulin, an assistant professor of environmental toxicology at UC Davis, who was a principal investigator in the research. These have to be stained a lot to pick them up from space, he said. So this right here is a video that the UC of Davis put out. We're just going to listen to a little bit of it.
We first observed a stream change color at a site that we were monitoring.
We were out there in 2017. Everything was great. We were collecting fish, collecting macroinvertebrates. And then we came back in 2018, and the whole river, whole small tributary had turned orange.
At first, when we saw this color change, we thought it was somewhat anomalous.
I couldn't find any fish in the stream. The macroinvertebrate community had been kind of decimated.
It was interesting, and that we should collect all the data we can to understand it.
Really startling to see. You're in this remote part of Alaska, no one's around, and these rivers are orange.
And then all of a sudden we realized this phenomenon wasn't just this one-off from 2018.
Now we have over 70 observations of streams and rivers that have changed color.
And I'm very interested in understanding the consequences of this.
And a little further down here, it says some of the consequences. It says the problem is growing and affecting habitat, water quality, and other ecological systems, turning healthy areas into degraded habitats with fewer fish and invertebrates. rural communities rely on these rivers for drinking water and for, the fish, and they could require treatment eventually, and the fish stocks that feed local residents could be affected. They said there are lots of implications. Another one is this other article here talks about how the water is becoming acidic. Yeah, and they said that these waters are becoming so acidic that some of them are registering pH levels of 2.6, or between the equivalent of the acidity of lemon and orange juice. So, yeah, that's pure water has a pH value of 7. Rivers and lakes typically have a pH value of 6.5 to 8, and acid rain has a pH value of 4.2 to 4.4. So the lower you get, the more acid, is in there. And right now, some of these are registering below acid rain at 2.6. So, that's another consequence. So much so that they say that the region has already suffered the complete loss of 2 fish species due to the acidity. So they say chum, salmon, and whitefish are also at risk of population decline. Right, because of the acidity. They said the changes could be devastating for indigenous tribes in the region who rely heavily on fishing. And they say that 75 streams observed were scattered across northern Alaska of a span about 600 miles. And, all of them, of course, northern Alaska, are in a remote area, miles away from human activity that could impact land, such as roads or mining. So, they know it's not coming from that. And what they think it's coming from is that the permafrost. The one hypothesis is that the permafrost, which is essentially frozen ground, stores minerals, and as the climate has warmed, the metal ores that were once locked up in the frozen ground were exposed to water and oxygen, resulting in the release of acid and metals. So they said that chemistry tells us minerals are weathering. Yeah, understanding what's in the water is a fingerprint as to what occurred, obviously, but they think that this is because the global warming is not real, so nothing's happening on this planet because of it, except it seems to be true that the permafrost up in the Arctic areas is melting. I did videos. There's lots of information about the methane craters because of the melting permafrost. And so that land has just been locked up year round, frozen. And now in the summer, it's thawing. It's becoming unfrozen, and so all of the metals that are in it apparently. They believe are, rusting the rivers, as they say here. And here's just what it looks like on a shore in some place up there. So here's where they've, identified where a bunch of the rivers and streams that are affected are. Okay, and now here is one of the researchers themselves talking about what they think's going on.
Our working hypothesis is that the thawing of permafrost soil is allowing water to infiltrate deeper and interact with minerals that have been locked away for thousands of years. And those minerals are weathering or undergoing a reaction with oxygen in the water. And then when that water then enters a river, the pH increases and a lot of the metals precipitate out. And the one that we see most visually is iron, why the rivers look like they're rusting.
And these rusting waters, again, as they say, are so large that you can see them from space. And this is another picture that they show right when they say that you can see it from space. So, all the naysayers out there, global warming is not real. You know what? I don't know if it is scientifically. Who knows? But as I say here, it's irrelevant. Everything that is said to cause global warming causes so many other problems that it's just responsible to live responsibly. And right now, one of the consequences of things allegedly seem to be getting warmer because this permafrost is thawing is that Alaska's pristine rivers are having these problems, and it can affect the local communities, even into tourism. People go up here to fish and, go up to these parks in these rural areas, and they don't go up there for rusted water. Usually they go up there for pristine conditions. And, if you may not be able to use this water, or you can't fish in it, who's going to go kayaking in this much acidity? So the impacts are deep, people. Stay tuned.